In this section, we're going to go ahead and take a look at the three different types of discontinuities. You should be very familiar with this already, but it is important because there's a lot of times when we in class that say at this jump discontinuity, or this removable, and if you don't understand what I'm talking about, you're going to get a little bit lost. And I'll show you there's a little confusion between jump and removable, and I'll show you that confusion. But let's start with looking at this picture here. So jump discontinuity is when your limit from the left and the right are different. And you can see that it's in order to, like, if you were a person trying to walk along this, and you're going along this, and let me just, here I am. In order to go from here to the next spot, I got to jump up, right? So that's something that we got to do. So that's why that's a jump discontinuity. This one is called removable. Think about it. You're just going along the function, everything's great, and then boom, all of a sudden a point is removed. Now this is where people get confused. Sometimes they think of, the point can be placed elsewhere. This is still considered removable even if the point is there. It's still considered removable just because the limit right there at that particular spot, everything is just, acting like a line here, and then all of a sudden, just right there, it's removed. But people think of this as jump because they think it's like, I get right here and then I jump up and then I continue. But that's not a jump, all right? This is a removable. Here's the jump where the limit from the left and the right are different. Then last, pretty obvious, the infinite discontinuity or the vertical asymptote right here. That one's super obvious. Not going to go too much into that. So in this assignment, really easy. We're just going to identify the x value of the particular type of discontinuity. But like I said, it's important to really get this down. So this is the graph of the function f. Dashed lines represent the asymptote. So you see the asymptote here when x is 4. We're answering with the x values. So select the x values for which f has a jump. So right here, this would be our jump. The limit from the left and the right are different. So x equals -2. So usually we answer with, if it's asking where it occurs, we're answering with that x value. So it occurs where x is -2. So look at this one. Select the x value in which f has a removable discontinuity. So right here's a vertical asymptote at -1, but what about right here? This is at -3, it's been removed, and also at 6 we have a removable. So I'm going to put x equals -3 and 6. Let's look right here. Select the x values in which we have a removable. Again, we see removable. So this is a jump. Then this is a vertical asymptote there. Vertical asymptote there. I don't see anything that's removable here. So I'm going to put none of the above, or none. I'm sure, in the selected response for this question, they'll probably say none of the above. We'll put none. Then last, we're going to look for that infinite discontinuity. And I'm wanting to say that I put a particular type of question. Oh, I picked this one here for a reason. Sometimes people get a little confused when there's like a sharp turn. They think sharp turns aren't okay, but sharp turns are okay. It's if that point's been removed, that's when you have that discontinuity. But this is continuous, even though it's going crazy. Right there's a jump, and these are horizontal asymptotes, but no, an infinite discontinuity is at the vertical asymptote, which is right here when x is 5. We'll talk more later about the horizontal asymptotes, but don't have anything to do with continuity. It's the vertical asymptotes that it wouldn't be continuous at, because at that x value, you can see it's not connecting and it doesn't exist.